This is Pre-Calc section 6.5, part 3, solving a system of three equations using Cramer's rule. We did Cramer's rule in the previous video for a 2x2. This is the process for a 3x3. It is the same process. It just takes longer because there's more matrices and because there's more work in finding the determinant of a 3x3. So our first thing is to fill in the coefficients into the matrix here, 4, 3, 2. Negative 1, 1, negative 1, 3, 1, 4. And before we do dx, dy, and dz, I want to evaluate the determinant of the D matrix, because we know if the determinant equals 0, then we cannot finish using Cramer's rule. So I'd like to find that out before I take time to fill in all these matrices. So the determinant here, I will do the diagonal method. When you have to evaluate the determinant of a 3x3, it is your choice. I like diagonal methods, so that's what I'm going to do. 4 times 1 times 4 is 16, plus negative 1 times 1 times 2 is negative 2, plus 3 times 3 times negative 1 is negative 9, minus parentheses. Now I'm going to do the up diagonals. 2 times 1 times 3 is 6, plus negative 1 times 1 times 4 is negative 4, plus 4 times 3 times negative 1 is negative 12. Do the outside here. 16 minus 2 is 14, minus 9 is 5, minus 6 minus 4 is 2, plus a negative 12 is negative 10. 5 minus negative 10 is a positive 15. So the value of the D determinant is 15. It is not equal to 0, which says go ahead and complete these matrices. So the dx matrix, because we will be using the dx matrix to find the answers for x, we're going to put the constant column into the x column. Your y and your z column remain what they were, which is negative 1, 1, negative 1, 3, 1, 4. Your dy matrix, we're going to use the dy matrix to find the answer for y. So put your constants into the y column. And your x and your z column are what they were originally. So 4, 3, 2, 3, 1, 4. The dz matrix, you're going to use this to find the answers for z. So put these constants into the z column. Your x and your y column should be what they were originally. 4, 3, 2, negative 1, 1, negative 1. And then you want to double check that you have copied everything correctly before you start doing any arithmetic. I evaluated the determinant of the D matrix by the diagonal method, but I notice in the dx, dy, and dz that I have these columns that have zeros in it, which makes it a lot easier, in my opinion, to do expansion by minors. Since I have zeros in this column, I'm going to expand on the first column. So I take the coefficient of negative 3, which is in a positive position. Remember, your negative positions are the 4 that make that diamond configuration, so that stays in the positive position, so the coefficient stays what it was. And then I can strike the row and the column, and what's left is 1, 1, negative 1, 4, which will be negative 3 times the determinant of that 2 by 2. 1 times 4 is 4, minus negative 1 times 1 is negative 1, so this is negative 3 times 5, which gives me negative 15. So the dx value is negative 15. This is getting kind of messy here, so I'm trying to box up or circle answers that I'm going to need. To do dy, it's the same thing. I would like to expand now on this column. So I put down the coefficient of negative 3, but I notice that negative 3 is in a negative position, so it's going to go back to a positive 3. Strike the row and column, and what's left is this 2 by 2 matrix. So this is 3 times this determinant. 3 times 4 is 12, minus 2 times 1 is 2. So this is 3 times 10, which is 30. So the dy value is 30. dz, there's my column with the zeros in it, so I would like to expand on the third column. That negative 3 is in a positive position, so I leave it alone. I strike the row and the column, and I have this determinant. So this will be negative 3 times 3 times negative 1 is negative 3, minus 2 times 1 is 2. So this is negative 3 times negative 5 which is positive 15. So those are my values for the determinants of those matrices. Now I have to use the fact that x is dx over d, which is dx is negative 15, d is 15, so x is negative 1. To find y, I will do dy over d. dy is 30, d is 15. 30 divided by 15 is 2, so y is 2. And then I'll squeeze this in over here. Z is dz over d, which is 15 over 15, which is 1. So z is 1, which makes my ordered triple for this solution as negative 1, comma 2, comma 1. And you can check that by plugging negative 1 in for x, 2 in for y, and 1 in for z, and that does check. So sorry this is such a mess, but I just can't squeeze it all in on one page. So let's look at another one. This one right here, I'm only going to fill in the matrices and not do all of the arithmetic. I just wanted to do that because this has got some missing letters, and I just want to remind you about some zeros. So this will be 5. We have a y, negative 1. We do not have a z. We have a 3 for x. We don't have a y value. We have a 2 coefficient for z. We do not have an x value. We do have a y. We do have a z. So be careful when you fill into that matrix to begin with. Now there's a lot of zeros here, but they're not in a particular row or column. So I would not do this by minors. I would do this with diagonals. So this is 5, 3, 0, negative 1, 0, 4. Down the diagonal, 5 times 0 times 3 is 0. Negative 1 times 2 times 0 is 0. And 0 times 3 times 4 is 0. Minus, up the diagonal is 0. Plus 4 times 2 times 5 is 40. Plus 3 times negative 1 is negative 9. So all that stuff outside is just 0. Inside here is 31, so this is 0 minus 31 gives me a d value of negative 31. That's important since it's not equal to 0. That says go ahead and continue. Now all I'm going to do is fill in the matrix and tell you what the determinants are, and you can work that out on your own, doing whatever method you want. So my dx, I'm going to put these constants into the x column, and then go back and grab these original ones, negative 1, 0, 4, 0, 2, 3. The dy matrix, we're going to put the constants into the y position, into the y column. And your x and your z columns stay what they were originally. dz, you're going to put the constants into the z column, and your x and your y columns stay what they were originally. And I will tell you that the dx determinant value equals 0. And it's okay for dx, dy, or dz to equal 0. It's just that d can't equal 0. The dy value is negative 124. And the dz value is negative 62. So to find x, I put dx over d. So that is 0 over negative 31, which gives me 0. To find y, I put dy over d, which will give me negative 124 over negative 31, which is 4. And to find z will be dz over d, which is negative 62 over negative 31, which is 2. So my ordered triple is 0, 4, 2. And you can check those by plugging them back into the original equations. All right, this one, I've already got the D matrix written out just to save a little bit of time. And to save a little bit more time, I'm going to tell you that this determinant equals 0. Because the determinant equals 0, that tells me that we cannot use Cramer's rule to continue this. It also tells me if the determinant is 0, it is either no solution or it is infinite solutions. I want you to look at, once you decide it's one of the two of these, I want you to look at ratios like we did on the 2 by 2, but you have to look at them pairwise. You'd have to look at the first compared to the second. So looking at that ratio is 2 over 5, 1 over 1, forget that. That's not going to tell me anything. So that little pairing didn't help any. Then I look at the second compared to the third. 5 over negative 2, negative 1 over 1, nope, those aren't equal. That's not helping me. But if you look at the ratio of the first and the third, 2 over negative 2, negative 1 over 1, 3 over negative 3, 1 over 2. 2 over negative 2 is negative 1, negative 1 over 1 is negative 1, 3 over negative 3 is negative 1, but they are not equal to 1 over 2. This is the same conclusion we had when we looked at the 2 by 2. If these ratios are all equal, but they're not equal to the ratios of the constant numbers, that tells me it's no solution. So that's a pretty easy way to determine no solution. You get a determinant equal to 0, you check out the ratios, and we can come up with the no solution conclusion because equal, 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 but not equal over here. On the other hand, I've done the same thing here. I have the D matrix written out right here. The determinant of this matrix equals 0, which tells me it is either no solution or it is infinite solutions. So I look at the ratios. Negative 2 over 5, that's negative 2/5, negative 2 over 7, that's not helping me any. Same thing looking at the row 2 compared to row 3, no. But take a look at these two. This is negative 2 over 2, negative 2 over 2, positive 3 over negative 3, 4 over negative 4. Negative 2 over 2 is negative 1. Negative 2 over 2 is negative 1. 3 over negative 3 is negative 1. And 4 over negative 4 is negative 1. That tells me it is infinite points. Now this is going to require a little bit more work to get our solutions. Remember, when you come up with an infinite solution, you eventually have to give an ordered triple in terms of z. So it will be something, comma, z. Now what I would do to come up with the x and the y expressions, I would go back and solve this by elimination. Now if you do elimination on these two equations, you're going to get 0 equals 0, and that's not helping you any. So I would do elimination on these two and eliminate either x or y. Do not eliminate z. So taking those two together, if I multiply this one through by 5, my new equation is negative 10x minus 10y plus 15z equals 20. Multiply this through by 2, I have positive 10x plus 14y minus 2z equals 4. Cancels out. I have 4y plus 13z equals 24. And that equation is good for me to solve for y and get a solution in terms of z. So subtract 13z from both sides. I have 4y equals 24 minus 13z. Divide everything by 4. And this will work out to be y equals, I'm going to go ahead and cancel this out. 24 over 4 is 6 minus 13/4 z. That is my expression for y. 6 minus 13/4 z. I have to come up with an expression for x, and I'm going to have to use one of these equations and plug in what I know for y and for z. But I had to clear out some space over here so I could continue this. I'm going to use this bottom equation, 2x plus 2y minus 3z equals negative 4. At this point, I can use whatever equation I want. I chose this one because it's smaller and positive numbers. So I'm stuffing in x stays x. Y is 6 minus 13/4 z minus 3z equals negative 4. So cleaning up a little bit, 2x, distribute the 2 is 12 minus 13/2 z minus 3z equals negative 4. X is staying over here. I'm going to subtract 12 over and get that out of the way, so that's now negative 16 over here. These are like terms. You can use your calculator if you want. Type in negative 13 halves minus 3, or get a common denominator right here, and this will be minus 19z over 2. Solve this for x. So add 19 halves z minus 16 over here. Finish solving by dividing everything by 2. And be careful, those 2's don't cancel. Dividing by 2 is like multiplying this by a half. So this becomes 19 fourths z. 16 divided by 2 does give me 8. So in my x position is 19 fourths z minus 8. And remember what that is. That is the generator of all of the points that would be solutions to this system.